Hello, I am Ludo Vallet. I'm the Director of Global Sales of Aquacycl, and welcome to Wastewater Wednesday. Today I would like to talk to you about the power saving associated with side streaming, or also known as process separation. For that purpose, I will go through a theoretical example of the two different configurations and highlight the benefits of those. So in the first case, let's imagine that we have just a single flow that goes through your process land. For ease of calculation, I'm gonna have some round numbers. So let's imagine that this flow is 100,000 gallons per day, and it has an average of 2,000 milligrams per liter, or ppm, of BOD. So that would require, according to standard calculation, roughly 6 kilowatt hours per kilo of BOD, and that would sum that to a total of 4,712 kilowatt hours per day. If we make a rough average of 8.45 cents per kilowatt hours, that totals gets to $145,000 per year. Pretty straightforward, nothing really tricky about that. Now let's have an example with process separation. So by process separation, we mean that we are treating the water in two different ways at the same time. So let's imagine for the separation, let's imagine that we have one flow that would be 90% of the existing flow. So let's put 90,000 gallons per day. And in that flow, we have less concentration because it's just the general flow of your process of your plant. And let's put it like it had 200 milligrams per liter of BOD. On the other side, we may have, like, for example, in the food and beverage, like a CIP rinse that would have the first rinse would have a higher concentration, and that would be obviously a smaller flow. And that could go through our containerized system, and that would be the complement of the 90,000, which is 10,000 gallons per day. And then would have a concentration of 18,200 milligrams of 30 of beer. To treat that water in in our system, it would require only 16 kilowatt hours per day. Let's imagine that after the treatment, we managed to remove 85% of that BOD. We still have a remaining 2,000. Let's track 2,700 liters. Let's imagine that we have removed 85%, and that we will have, as a result, a concentration of 2,700 milligrams per liter of BOD. We would then combine that flow of our batch system with the remainder of the general flow, and we consequently have back our 100,000 gallons per day at a concentration of 453 milligrams of BOD. So since we have less concentration for that treatment, the energy consumption will be much lesser, and we will need 1,067 kilowatt hour per day to treat that water. So the total consumption for the entirety of the treatment will then be 1,127 kilowatt hour per day. Those 1,000 is to be compared with those 4,700, and the cost is in line, and that would be roughly $35,000 per year, which means a total saving per year of $110 per year. So with simply having a process separation, you really benefit on multiple levels. Of course, you save energy. Of course, you save money, but you also have ripple effects because you will need an investment much lesser on the conventional side, and you will have less sludge to manage because the concentration are lesser, so you have less things to bring to the treatment plant. So you also will have less CO2 emission associated with the general treatment of your plant. So these are all things to consider in order to benefit from the process separation and have a more cost-efficient system.